Hi, my name is Jesse Cassidy, and I'm here today to talk about the combined small-scale energy system that I've developed as part of EGE 320, the International Experience, here at the University of Mount Union. As an introduction to this project, we focused in class on many of the problems that people in developing countries face on a day-to-day basis, and often they are problems that people in developed countries such as us in America take for granted. Some of those issues are the lack of electricity, the lack of clean, safe toilets, and malnutrition that can occur among the community. These problems are very striking, especially malnutrition, because it affects very many children, and it can be fatal and deadly. And lack of electricity, many people that live in first world countries take electricity for granted, but it allows us to cook our food, refrigerate our food, have air conditioning, a lot of things that aren't available in developing countries. And some of those, such as refrigeration of food, can be very, very important when you're dealing with other problems such as malnutrition. For the lack of clean, safe toilets, this can pose a very serious health problem to pretty much the entire community, especially when you're dealing with human waste, because if that's not disposed of properly, it sits and many children and adults can be exposed to that in the community, leading to various bacterial problems and possibly even death. So these are issues that need to be addressed in developing countries, and these issues are issues that can be addressed with engineering solutions. So for current technology that addresses these issues, they're mostly on the large scale. For this project, I'm looking at waste-to-energy facilities that burn trash to produce energy, as well as anaerobic digesters that digest and process human and animal waste to generate fertilizer and biogas, which can be burned for energy. The current technology related to both of these, the current technology for both of those technologies are on the large scale and are not very applicable to developing countries and their needs. For the waste-to-energy facilities, that's mostly done on a statewide or, in America, county-wide basis. A study was done on the country of Sweden, which is very adept at using their waste-to-energy facilities. 90% of Sweden's garbage is turned to energy, as opposed to 12% of the US's garbage. It's possible to achieve total energy independence through this technology, but more than that, when you're dealing with developing countries, it's important because oftentimes trash is strewn about and not disposed of properly, often ending up in landfills or just out in the streets, which can pose very serious health risks. So the problem definition moving forward with this project is the lack of clean, safe human waste disposal systems, the lack of electricity, and the malnutrition that's present in developing countries. So I set about creating objectives that would address these issues. The first objective is to provide a solution to the human waste disposal issue. This would help many community members in developing countries, especially in rural areas, deal with their waste disposal issue. And if there was a way to generate electricity and allow for more production of crops while dealing with these problems, that was what I wanted to achieve. The methodology for going about solving this problem using these constraints and those objectives, the first and most important one was to develop an innovative solution. It had to be something new or take an existing technology and innovate it in a new way that had never been thought of before, that was a way that could be applied to people in developing countries. So I decided to go about designing a small-scale trash burner and anaerobic digester system that work together to provide energy and various other helpful advantages to people in small villages in developing countries. It was important that it was manufactured using inexpensive materials that could be assembled by people with low educational experience. The most innovative part of this was the combination of the two separate technologies, the trash burner and the anaerobic digester. Here you can see a 3D model of the anaerobic digester. This was the part of the project that was focused on in the report because it provided the most immediate effective solution to people in developing countries. This is, it can be closed by a lid. These are the two inlet holes where the waste would be deposited into the two separate containers. The volumes of these containers and the dimensions of the actual digester are listed later in this presentation. And this outlet is for the biogas, that a pump can pump this out and then a compressor can compress it so that the gas can be stored and used. Here are the dimensions of the different sides. This is the short side, where this is the outlet for the biogas. It's a 12-inch diameter hole, and the dimensions of the base are 50 inches wide by 48 inches tall by 300 inches long, which is 25 feet. So, moving forward, the operation of the anaerobic digester, it operates as follows. There's a holding tank above each of the inlet slots where the human waste is deposited. Once every other day, that has to actually be emptied into the digester. It can't just lead directly into it because the digester has to stay airtight to allow the chemical reaction to take place. So once every other day, it has to be emptied into the main container. That way the airtight container can stay airtight as it's supposed to. Before you dump from the holding container into the main container, a bacteria tablet has to be introduced and then is placed into the main container from the holding container. That bacteria is what facilitates the anaerobic digestion process. So it's very important to get the biogas and make sure that the process continues as it's supposed to. The digestion period is 9 months. So as you saw in the previous slides, the container is split into two separate portions by this divider down the middle, so that one side of the digester can be used, then it can be sealed up once it's full and digested for 9 months while the others being used on a day-to-day basis. So during that 9 months, the reaction is taking place and biogas is being generated, and it can be pumped out and compressed and burned for fuel. But after that 9 months, the leftover product that is in there is a fertilizer that can be used to grow a variety of crops. This is especially useful because in many developing countries the climate can be harsh or not suited to growing crops. The soil can be very hard, and this fertilizer would help community members to grow crops to help combat malnutrition. The environmental and economic analysis of this product is as follows. The price of the sheet metal for the entire product is $730. This can be brought down if it's manufactured in bulk. Each of the sheets, which make up the sides, will be assembled on site. The education level of the users is very important because sometimes in developing countries, many citizens do not have the educational level that many people in developing countries have. So it's very important that the users can assemble and operate this device even if they are illiterate or have a lower education level than us, and that's why the instruction manual is important. In conclusion, this combination digester and anaerobic digester and waste-to-energy trash burner system can provide solutions to many important problems in developing countries. It provides a safe, clean receptacle for human waste disposal, eliminating the amount of human waste that's present around children or other people in the community, which eliminates quite a lot of health risks. It provides a place for people to dispose of their garbage, which helps the ecosystem so that it keeps more material out of landfills so that the landfills fill up slower. And it also has a positive impact on the ecosystem because there's less trash lying around that could impact the wildlife. It also provides electricity through the biogas and the heat from the burning of the trash. This can be used to refrigerate food, which is its main application. It can be used to provide lighting in dark areas, which would make villages safer in developing countries, and as well as many other applications. Another application is the nutritional crops, which are grown using the fertilizer from the anaerobic digester. And that concludes this presentation. Thank you very much.